Chapter 14, Transformations. Today we're going to cover section 14.5, Dilations. Our objective will be to locate images of figures by dilation. When I think of this, I think of if you've ever been to the eye doctor and you've had your eyes dilated, they put some drops in there that make your pupils expand and get bigger. So I think of a dilation pretty much as that. Imagine taking some center point and expanding everything out from there. So as we go through the definition for a dilation, think of just expanding for the most part. So dilation is a transformation that changes size. The dilation DOK has center O and non-zero scale factor K. DOK maps any point P to a point P prime determined as follows. So think I'm going to explain how to expand the shape. So if K is bigger than 0, P prime lies on ray OP and OP equals K times OP. I'm going to explain what that means before I even go to the next part. So imagine down here I had points A and B, and I told you that this K value was 2. All that means is every point would get twice as far away from the center. So if I looked at the distance from O to A, I would make it twice as far away. So it would end up coming out here, so that the distance from O to A prime is twice the size. And the same thing from O to B. I would just make it twice as far away, which would put it out here. So that's all that's happening. Then I can even connect them together to get my triangle. So if the K value is bigger than 1, it just makes the object bigger that many times. And if K was 3, it would make it 3 times as big. If K was 4, it would make it 4 times as big. So there's what's happening when K is bigger than 1. Okay. Now let's look at the second part up here. What if K is less than 0? Then P prime lies on the ray opposite of ray OP, and OP prime equals the absolute value of K times OP. Right. Here's all this one means. Imagine I pick K is -2. My shape is going to get twice as big like before, but it's going to get twice as big in the opposite direction. So if I put A and B back in here. So if K is -2, the distance from O to A is going to double, but it's going to double going in the opposite direction. So it's going to end up coming this way, and here's my A prime. Twice as far away, opposite direction. And then the same thing would happen for B. To get to B prime, I would end up just going the opposite distance away and twice as far. So everything got doubled in size. Negative means it went in the opposite direction. So at this point, just think if K is positive, it gets bigger. If K is negative, it's going to go in the opposite direction. And number 3, it says the center O is always its own image. So obviously, if I want to get farther away from O and you're already at the center, it's not going to change at all. Looking at the next part. If the absolute value of K is bigger than 1, the dilation is called an expansion. So that's sort of what we had back here in the beginning. If I told you that K equals 2, everything just got twice as far out. So here's my K equals 2 value. The original triangle got expanded. All the sides are now twice as long. So there would be an expansion. The other part says if the absolute value of K is less than 1, the dilation is called a contraction. So imagine if I told you that in this case the K value was 1/2. Now I would go to my triangle, and instead of making everything twice as the distance, I would only make it half the distance. So if I went half the distance away, I end up getting this smaller triangle right here, and it's called a contraction. So absolute values bigger than 1 are expansions, and the reason they have the absolute values, I could give you something like a -2, which would be an expansion, just going in the opposite direction. If you have numbers, absolute values less than 1 is going to be a contraction. So I could get something like -1/2, which would still contract it, but make it go in the opposite direction.